Shah from SPC Bangalore, Department of Computer Science and Engineering. Today I am going to discuss about the topic of elliptic curve arithmetic. Let's move on to today's agenda. Today's agenda includes thought, introduction, what are elliptic curves, elliptic curve arithmetic, applications of elliptic curve arithmetic in cryptography, elliptic curve Diffie-Hellman key exchange method, security of elliptic curve cryptography, limitations of elliptic curve cryptography, and finally conclusion and the questions. First off, introduction. Okay, welcome everyone. We are discussing about the elliptic curve arithmetic and its applications and cryptography, the limitations of traditional mathematical methods, and into the realm of cutting-edge technology. So, we will talk about this elliptic curve with their unique properties and a real revolution. We will talk about the topic of elliptic curve with their unique properties and have revolutionized the field of cryptography and opened up new possibilities for the secure communication. But before that, we will divide into the technical details. Let me point a picture for you. Imagine where your private information is constantly under the threat from hackers and cybercrime criminals. A world where every message you send, every transaction you make, and every piece of data you store is vulnerable to attack. Now imagine a solution that can protect from you these threats. Yes, that is a solution that uses the power of mathematics to keep your information safe and secure. And this is the world of elliptical cryptography, and it is the future of digital India and digital security. Now, I'm talking about elliptic curve. What is the means that elliptic curve? Let's see what is meant elliptic curve. Elliptic curve are the type of mathematical curve that have some unique properties. As I said previously in introduction, it has some unique properties. They can be defined via equation of the form y to the power 2 equals to x to the power 3 and a of x plus b, where a and b are the constants. That's parameter. This is the equation where we can mathematically express the define the elliptic curves. One of the most important property of this elliptic curve is that they are symmetric around x-axis. You all know about what is symmetry and what is x-axis and y-axis. According to that, the main property of this elliptic curve is that it is symmetric around the x-axis, which means that is if x or y is on the curve, so is x minus y, which means that if x comma y is on the curve, then so is x comma minus y also. The another important property of elliptic curve is that they have a group structure. The structure is of grouped, and which means that can perform the operation like addition, multiplication as on the curve only, and the points on the curve only. We will use that mathematical operations, additions, multiplication on normal plane or any lines, or we can use it in a excessive y-axis. Same like that, elliptic curve has important property. It is a group structure, and it can perform addition and multiplication on the points on the curve. On the curve. This makes that useful in cryptography, because we can use this operation in encrypting and decrypting the messages. So, for example, we can use the Diffie-Hellman key exchange algorithm to securely share a secret key between the two parties using the elliptic curve. What is Diffie-Hellman key exchange algorithm? How it is helpful, and how the elliptic curve is going to help in this? How it has become an example for this? Let us see in a further slide. I'll discuss about it later. First, we will see what is elliptic curve arithmetic. The elliptic curve arithmetic is a topic that involves the performance of mathematical operations on the point that lies on the elliptic curve. As we discussed that elliptic curves as a point on the curve, that is the mathematical operation which are done on those points is called as an elliptic curve arithmetic. Unlikely traditional arithmetic which deals with the numbers, elliptic curve arithmetic operators on a point. So as we see the traditional arithmetics which we have used in our school days or college days, whatever it may be. So mathematically, if we use this operation addition, multiplication, subtraction, divisions around the numbers. But in the case of this elliptic curve arithmetic, we use these operations on a points where it is marked in a curve, and it uses the different set of rules to perform this addition and multiplication. And the major difference in the traditional method and this elliptic curve is that it uses a set of rules to perform this addition and multiplications by hand. To add 2 points on elliptic curve, we have drawn a line through up 2 points and find where it is intersects the curve. So we have to add the 2 points on elliptic curve. If we suppose, so we have to draw a line through the 2 points and find where it intersects the curve. This intersection point is the sum of 2 points. As I told, those intersection points are the sum of 2 points to the multiplication a point by a scalar value. As you know that we have learned about scalar, vector and also. So these when we have to multiply the point by a scalar value, we will simply add the points to itself repeatedly until we reach the desired scalar value. So for the multiplication, we are going to repeatedly add the points itself until we reach the desired scalar value. Scalar value is the multiple value of two multiplication value of the points in our elliptic curve. So next we will discuss about this applications. Applications of this elliptic curve in arithmetic in a cryptography. So this elliptic curve or arithmetic is a major concept of cryptography. How we'll see this in this slide. Elliptic curve arithmetic has a wide range of applications in a cryptography, making it as a crucial tools for surviving sensitive data. Elliptic curve arithmetic has a wide range of application in cryptography, making it as a crucial tool for securing the sensitive data. One of the main advantages of this elliptic curve cryptography is its ability to provide a same level of security as others method with a smaller key size, which results the faster computation and reduced memory requirement. So we all know that cryptography means that encryption and decryption of the messages we have sent to the client and between the server. They use the keys, which is in other normal methods we use a large key for the large data, but in this case as an elliptic curve arithmetic, we have the major advantage in cryptography that for the large amount of messages we need only smaller key size to secure that, and it employs the faster computation and reduce the memory requirements. The major problem of this technologies are memory, that is can be resolved from this in cryptography. This makes it an ideal choice for the resource constrained devices such as mobile phones and smart cards. This is the memory requirement, and the faster computation is a major advantage to choose this as an ideal choice for the resource constrained devices such as mobile phones, smart cards and mobile phones. It's small, tiny gadgets we use, and we have huge security, and it requires a small size key only. The another advantage of this elliptic curve in cryptography, it is resistance to attack based on the discrete logarithm problem, which is used in many other cryptographic methods. We have several cryptographic methods, but in this particularly, we are not using this discrete logarithm problem, where this thrown to the attack of hackers and cyber criminals. So we can prevent that from the using the elliptic curve arithmetic. This makes it as a popular choice of digital nature, key exchange, and other cryptographic protocols. In fact, many modern cryptographic systems, including TLS and SSH, now use elliptic curve cryptography as their default algorithms. Now, what is elliptic curve cryptography? We shortly call it as a ECC. It's a powerful cryptographic method that offers several advantages over traditional method. As we discussed about elliptic curve or arithmetic in cryptography, same as that. That is the major algorithm for this elliptic curve cryptography. Unlike the other methods, like any other traditional methods, elliptic curve cryptography uses a property of elliptic curve to generate and exchange keys, making it highly secure and efficient. As I told, it uses the properties of elliptic curve to generate and exchange keys, making it highly secure and efficient. One of the major advantage of this elliptic curve cryptography is ability to provide a small level of security, same level of security as other methods while using smaller key sizes. As I told that this cryptography, elliptic curve cryptography uses smaller key size for giving the security for the same level of messages or any other communications between two parties. It is using the smaller key, which means gives an large difference between other traditional methods and this elliptic curve or cryptography, and this makes it an ideal for use of constraints environments such as mobile devices and IoT devices, as we discussed previously. Additionally, elliptic curve cryptography can be used to create a digital signature and performs a key exchanging method. It is a versatile tool for securing communications. Now, let us discuss this with an example. As I told, this is an base algorithm for a method called different element key exchange method. Let us see what is it all. Okay. Come to that example. Elliptic curve different element key exchange. What it means? Shortly, we will call it as ECDH. Is a key exchange method that allows two parties to securely share the security key over a insecure communication channel. This is mainly on where we can use its insecure communication channels, some other third parties channels, third parties apps. We will use this key exchange method to protect the two parties conservations communications. It works by the each party generating their private key and the public key pair on a elliptic curve. This has a method of working like that. Each party, two parties will generate both private key and public key on an elliptic curve, and they exchange their public keys while communication. They share their secret key in the derived independently by each party using their own private key and others public key. How they will extract the message, how they will communicate after that, how they will decrypt that message means they will exchange this public key for each other, and they have their own private key. Using the private key of their own and public key of the other party, they will decrypt the message and decode it. Compared to the traditional key exchange method like RSA, ECDH offers several advantages. We have RSA algorithm for this communication between two parties, but we have some disadvantages in that. Over that, this elliptic curve Diffie-Hellman key exchange method has several advantages compared to that traditional key exchange method. It is a faster, requires very small key size for the same level of security, and it resists to attacks from the quantum computers. The quantum computers have a huge amount of data loss, and it attacks many data and communication between two parties where it should be secured and for the future, and it should be secured. And these properties makes elliptic curve Diffie-Hellman as a popular choice for secure communication protocol like TLS and SSH. Now, the securities of elliptic curve cryptography is going to be. It is considered to be a secure method of encryption, but it is also insensitive for the attacks. There are some attacks on this also. Can be happens on this also. Elliptic cryptography. One of the most common attack on this elliptic cryptography is Pollard's law algorithm, which can be used to find the private key in an ECC system. Another attack is the elliptic descriptive logarithm problem, which involves finding the descriptive logarithm of a point on an elliptic curve. However, these attacks can be mitigated by using large key sizes and carefully selecting the parameters of elliptic curve. In addition to these attacks, elliptic curve cryptography can also be sensitive to the side channels attacks, which involves the exploiting weakness in the implementation of the cryptographic system rather than the algorithm itself. For example, an attacker could use the timing or power analysis to determine the private key. To mitigate these attacks, countermeasures such as randomizing the input data and using the constant time algorithm can be employed. Now, let us see the limitations of this elliptic curve cryptography. While elliptic curve cryptography has many advantages over other cryptographic methods, it is not without its limitations. One of the major limitation potential is that for quantum computers to break the underlying mathematical problem that elliptical curve cryptography relies on. The research in past quantum cryptography is focused on deploying the new methods that are resist to attacks from the quantum computers. Another limitation is the computational complexity of elliptic curve arithmetic, which can make it difficult to implement on a certain devices which is limited to computing power. However, ongoing research in optimizing the technique and hardware acceleration is aimed to making the elliptic curve cryptography more efficient and accessible for a wider range of applications. This is all about the elliptic curve, arithmetic, and cryptography. Now we are come to the end of the session, that is conclusion. So what we have learned in this session is means that elliptic curve are mathematical objects with the unique properties that makes them ideal for cryptographic applications. We have explored that how it is arithmetic performance on the elliptic curve and how it differs from traditional arithmetic. We discuss about advantages of using elliptic curve cryptography or other methods and provides example its use in a real world applications. We also discuss about the security elliptic curve cryptography and its insensitive to attacks. It is clear that elliptic curve arithmetic has revolutionized the field of cryptography and has become an essential tool for securing our digital world. As we continue to develop new technologies and faces new threats, the importance of this elliptic cryptography will only continue to grow. We must continue to invest on this research and development to improve the security and efficiency of elliptic cryptography. and it is ensure that it remains a cornerstone for our digital infrastructure. Thank you for your attention. I hope this presentation has been informative. Now it's time to open up your floor for questions and discussions. If you have any questions, let me know in the comment section. Thank you so much. Thank you for watching. Please share and subscribe this channel. Thank you. Bye.